The History of Articulators by Secure Dentures. By the end of the presentation, you will have 1. Increased your understanding of articulator design. 2. Know more about why modern-day articulators struggle to reproduce a patient's functional movement. And 3. How human anatomy differs to the modern-day articulator concepts. This presentation will cover how our occlusion principles came about, William Bonwill's equilateral triangle, the Bulkwell angle, George Monson spherical theory, Bernard Frank's counter theories. Like many sciences, the history of dentistry is rarely taught in our training or even considered in our daily practice. This is particularly true of the development of articulators. Articulator manufacturers usually state that their articulators are based on the occlusal concepts of the Bonwell triangle, the curves of von Spee and Wilson or Monson, the Bulkwell angle, and the Camper's line. Our clinical experience has led us to question the occlusal concepts that form the basis of most of our occlusal practice, and by implication, the nature of articulator design. It is frustrating when the function produced on dentures constructed on present-day articulators is not reproduced when transferred to the patient's mouth. We also have to consider the profession's desire to provide beautiful anatomical cusp forms. However, anthropology demonstrates that cusps are not needed to provide good function in the human dentition. It is normal for cusps to be worn down to a much flatter occlusal form in the mature dentition. So why do we work with equipment which is poor in reproducing natural functional movements and create denture occlusions with steep cuspal forms? There is little or no science-based knowledge in the field of occlusion. Our knowledge of occlusion is based on the opinions of our teachers who acquired their knowledge from their teachers and so on down the years. It's probably the way you learnt about occlusion too. Studying the history of our current occlusal concepts, it becomes clear that they are mainly based on the ideas of Bonwell and his contemporaries of the late 19th century. So the techniques we have been using are mostly the result of experts working with the evidence base of that time, well over 100 years ago. It is fascinating that concepts from this time have carried on pretty much unchanged, and the design of all our semi-adjustable articulators is based on them. The concepts expressed by William G. A. Bonwell is critical to our articulator history. He had clear opinions on how the different parts of the body related to each other, particularly in the head and neck. The proportions of the human body are founded on an equilateral triangle, most clearly manifest in the architecture of the jaws and teeth, exactly 4 inches on a side. Dr. Bonwell, 1899. The early work on articulators started in the 1860s. Simple hinge articulators became commonplace, but by the beginning of the 20th century, the natural variability of the condylar paths, both between individuals and from side to side in the same individual, were being recognized and appreciated as important aspects of mandibular movement. Dental scientists and inventors investigated the nature of mandibular movement in order to reproduce these movements in an articulator. However, the investigators' interpretations of what they observed varied greatly, and this is demonstrable in the features of their articulators. Even though there were differences in investigators' measurement and application of mandibular movement, the complexity of articulators began to evolve, mainly as a result of the important work of scientists such as W. E. Walker, Alfred Giese, and George Snow. By 1910, most inventors had become more systematic in their attempts to reproduce the individual natural movements of the mandible, and this became recognized as the condylar or anatomic school of articulator design. The most noteworthy example is the Giese simplex articulator, which, incidentally, caused quite a reaction from Giese's critics when introduced in 1912. However, intense competition in the marketplace and dentists' demands for simplicity led to the creation of average value instruments without adjustable condylar guides. A second major school of articulator design, the geometric or non-anatomic school, was emerging. This approach embodied principles contrary to the condylar school and proved to be both trend-setting and controversial. The geometric school denied the existence of condylar axes and disregarded the condylar paths as influences on occlusion, instead contending that the articulation of the teeth guides the mandible during mastication. The condylar paths need only be in accord with the plane of occlusion, which means you need only set up the articulator to the cuspal angles of the dentition. The inventors most frequently associated with the geometric school of mandibular movement and articulator design are George S. Monson for his spherical theory and Rupert E. Hall for his conical theory. Today it is Monson that is recognised as founding father of our current occlusal concepts. It was earlier investigators, however, who laid the basic foundations on which the principles of the various geometric theories were built. William G. A. Bonwill and Francis H. Borkwell, who were contemporaries, although oceans apart, were perhaps the earliest investigators to apply geometric principles to articulation, mandibular movement, and the design of articulators. In 1864, Bonwill introduced his equilateral triangle theory, establishing the size of the mandible as 4 inches from condyle to condyle and from each condyle to the incisor point. Bonwill believed that the articulation of the teeth guides the mandible during function, but that the centres of the condyles are also the centres of lateral rotation for the mandible's opening and closing movements. Borkwell presented his own observations on mandibular movement in 1866. When describing the opening motion, he theorised the opposite to Bonwill. Borkwell believed the articulating posterior outline of the condyle of the lower jaw was formed by parts of 2 circles, the inner and larger forming part of an independent smaller circle. The condyle articulates with the glenoid cavity so as to allow a single hinge-like motion and a forward and backward motion. Whilst there is only a slight lateral motion, both sides move on the radii of the same circle. He went further by saying, the combined motion of both circles will give the rotating side nearly a simple lateral action, while the orbiting side will move forward and downward. In 1890, anatomist Ferdinand Graf von Spee of Kiel, Germany, called attention to the relationship between the curved arrangements of the occlusal planes of natural teeth and the corresponding curves of the condylar paths. As reported by Giese, who was tireless in his resolve to promote his simplex articulator, von Spee described the forward movement of the mandible as viewed in the sagittal plane as a curve. This was later known as the curve of Spee. By 1918, several theories of occlusion existed alongside the articulators designed to promote them. According to James E. House, since the principles of these theories varied so widely, it was decided that in the best interest of the profession that a study club be created to decide on the most appropriate theory. The study club was limited to 50 men dedicated to testing their ideas on each other in a workshop setting. Their goal was to narrow the field of articulator design to one acceptable articulator for the improvement of prosthodontics. This was one of the primary reasons that led to the formation of the National Society of Denture Prosthetics and was organised in August 1919. However, it was rumoured that big business influenced the results of these gentlemen's findings, and because the industry needed a recognisable theory, the study club chose the geometric school of thinking. This meant that Bonwill's ideas, with the help of von Spee, Wilson and others like Francis H. Borkwell, helped create the forerunners of today's geometric linear articulators. To get a clearer understanding of Bonwill as a person and his beliefs, we must firstly understand the nature of the Victorian era that Bonwill lived in. Dental science was in its infancy, and there was a plethora of theories without the rigorous scientific testing that we expect today. Bonwill, like most of his contemporaries, held strong Christian beliefs. These feature in his description of how he devised his theory of occlusion. On cusps and arch forms, a system so beautiful and so mathematical in design cannot but call forth our admiration and wonder. Dr. Bonwill, 1887. and the study of no other part of the human body will give one a clearer idea of infinite wisdom. Dr. Bonwill, 1887. The form of the occlusion shows one the most striking designs of a great first cause. Dr. Bonwill, 1899. It was not unusual at this time to describe nature in geometrical terms. Bonwill made the assumption that the structure of the human body was based on equilateral triangles. He didn't actually take any measurements to validate his theory. One of the conclusions to be drawn from Bonwill's assumption is that the dimensions of both sides of the face are the same. Clearly, that is not true, but without realising it, modern denture prosthetics is still based on that assumption. Von Spee and Wilson created their geometric compensating curves around Bonwill's 4-inch equilateral triangles, using this dimension as the radius of their respective curves. The dimension of 4 inches is also used in the design of all of our modern semi-adjustable articulators. Bonwill's assumptions still influence dentistry today. The compensating curves we use in dentistry on a daily basis have not been developed through meticulous research. They have been created to match a set of beliefs. It is important to realise that these beliefs lead us to the conclusion that lateral movements of the mandible are the same on both sides, and the movement is of a linear nature, that is, a straight line. Semi-adjustable articulators of today have some significant limitations. In reality, lateral movements to the left are not the same as those to the right. It is also non-linear. And we should not forget the effect of compression of the tissues as a mandible moves under load. Today's articulators cannot represent true mandibular movements in these important respects. Fortunately, the study of dental occlusion and its relationship with mandibular function is progressing. There is now research evidence that compensating curves, such as Von Spee and Wilson described, do not exist in nature. This is also supported by full denture wear pattern observations from our clinical work. Previously, we discussed the credibility of Bonwill's triangle and the curves of Spee and Wilson. It is time to introduce George Monson into the history of occlusion. As we have previously stated, the major theories of denture occlusion were conceived in the late 19th century and have more or less remained unchanged up to the present day. Also, we have been frustrated by our inability to observe the functional denture occlusion created on a semi-adjustable articulator when the dentures are transferred to the mouth. Understanding the work of George Monson will go some way to explaining why we have these difficulties. To recap, in the early days of the developing science of occlusion, there were competing occlusal theories. Notably, the one that gained most credence was the School of Geometric Design. This school denied the existence of condylar axes and disregarded the condylar paths as influences in occlusion. Instead, they believed that the articulation of the teeth guides the mandible during mastication. During the early 20th century, there were two individual dentists working independently of each other using the spherical theory. Carl Christensen and George Monson were both conducting experiments on mandibular movements, yet neither knew of each other's work. As history now shows, it was Monson that has gained the credit for this work, though Christensen deserves a mention. In 1898, speaking to a group at Mankato, Monson presented for the first time a method for setting denture teeth conforming to the surface of a sphere based on Bonwill's 4-inch equilateral triangle. Monson had been a student and close friend of Bonwill for many years. This first demonstration of his spherical theory was performed with a Bonwill articulator, and the casts were mounted according to Bonwill's instructions. However, departing from Bonwill's concepts, the teeth were set to conform to a wire spherical occlusal guide constructed by Monson, as you can see in the picture. Through further studies, Monson concluded ideally that prenatal mandibles tend to develop as equilateral triangles, and if the various interfering factors can be controlled during development, that tooth occlusion would also conform to a sphere. To verify his hypothesis, Monson conducted experiments with both a human mandible and with casts of the mandibular dentition of highly developed individuals. By highly developed, he meant a person with an ideal mandible and dentition that had not been disturbed at some point by disease or development anomaly. Monson fixed in a metal rod to the central point of the occlusal surface of each tooth, projecting the rod upwards and parallel to the long axis of the tooth. These rods represented the radial lines of force of the teeth. When all the rods were in place, Monson found that they intersected at a common point or centre. On the human mandible, he discovered that when measuring from this common centre, a dividing caliper not only touched the incisal edges of the anterior teeth and the buccal and lingual cusps of the posterior teeth, but also bisected both of the condyles. This study was the origin of Monson's spherical theory. It was based on the concept that the mandibular teeth move over the occlusal surfaces of the maxillary teeth, as over the external surface of a segment of an 8-inch diameter sphere, and that the centre of the sphere is located in the region of the crista galli. The crista galli is a median ridge of bone that projects from the cribriform plate of the ethmoid bone. Because of the way in which the mandible develops, Monson further believed that it would be logical to adapt Bonwell's 4-inch equilateral triangle to the surface of the 8-inch sphere, because geometrically, such a spherical-based triangle would also be a segment of the 8-inch sphere and the apex of an erected pyramid. Perhaps you can see the difficulty we have with Monson's theory, as the evidence shows that Bonwell's triangle does not exist. Joining reference points from the condyles to the central incisors do not produce an equilateral triangle. Completely symmetrical faces do not exist in nature, yet this is the conclusion to be drawn from the occlusal theories of Bonwell and Monson. Where is the symmetry in this gentleman? As stated earlier, Monson's belief was that the articulation of the teeth guides the mandible during mastication. Dentures constructed with this concept means that the patient's function has to adapt to the occlusion produced on the articulator. Dentures constructed on the traditional semi-adjustable articulator have not accounted for the role of the temporomandibular joint in determining function. The articulator does not represent the individual patient's dynamic movements in function, have not taken into account the bones flexing under tension, or the muscles stretching and contracting. In reality, functional movements of the temporomandibular joints occur as a combination of masticatory muscle action and two physical guides, known as posterior and anterior guidance. Posterior guidance is the influence of the shape of the bony anatomy on the movement of the mandible, which means the influence the TMJ has on the jaw movement. The second is anterior guidance, and this is the influence of the shape of the occlusal surfaces on the movement of the mandible. Anterior guidance doesn't necessarily mean contacts on anterior teeth. It means contacts on teeth anterior to the TM joint, so it also includes posterior teeth. It is not specific to any particular teeth. In our opinion, in an ideal world, we would like to have these two guidances working together in harmony. The secure denture system takes account of the asymmetry of the patient's face and functional TM joint movements and enables the construction of dentures that perfectly match the dynamic function of the individual patient. Interestingly, even Monson's own diagram shows that not all of the occlusal surfaces of the teeth match the surface of his 8-inch diameter sphere, so why do we construct dentures to fit this model? Hopefully you will now recognise that studying the theory behind our accepted occlusal concepts helps understand their limitations and why we have some of the challenges in providing functional full dentures for our patients. And it is not only the articulating systems that we use that have these inbuilt inaccuracies, but also the denture teeth we use. They too are designed to be symmetrical on both sides to match the curves of Spee and Monson, and to match the linear movements of the articulators. Take it one step further and you will find our CAD/CAM systems also construct their frameworks to these curves. This could be one of the causes for a number of framework failures in the implant and crown side of our industry. Also why an implant retained lower denture produces an unstable upper denture. It could be said that we are at a crossroads in dental occlusion. Our understanding of mandibular movement is close to the theories of the condylar or anatomic school and individual asymmetric anatomy. However, our articulators and denture teeth are based on the geometric school, which assumes anatomical symmetry. Researching the history of occlusion has revealed that there was a dentist who questioned the geometric school theories of Bonwill, von Spee, Monson and Christensen. This was Bernard Frank of Amsterdam. In 1908, he wrote a paper harshly criticising von Spee's assertion that the sagittal occlusion curve of man has a radius of 6 to 7 centimetres, and that geometric articulators could imitate TMJ movements. Frank conducted experiments that he believed produced conclusive evidence that Spee's findings were inaccurate. He reported that his own experiments showed that this was the case in only 27% of his anatomical measurements. Frank also contended that Christensen did not prove the validity of his rational articulator. Using cross-sections of dentulous mandibular casts, Frank demonstrated that there were vast differences among individuals in the curvatures of the occlusal planes. Frank repeated his simulated functionally generated path experiment using blocks made of a pumice stone mixture. The curved occlusal surfaces generated on Frank's blocks were remarkably more complicated than the spherical surface reported by Christensen. Furthermore, Frank suggested that it was evident that the directions of the natural masticating surfaces differ so greatly from those obtained by repeating the experiment of Christensen that this experiment entirely fails to prove the correctness of the Christensen articulator. Bernard Frank's rhetoric was that of a man with a mission, to let the world know that it is utterly impossible to solve the problems of articulation by means of articulators. This was a brief but comprehensive insight into our articulator and occlusal history, and it goes some way in explaining why the denture patient, especially the edentulous denture patient, struggles to function effectively with the dentures we provide. History tells us that Frank's opinions did not gain traction in the world of dentistry, and the theories of Monson and the geometric school continue to dominate the designs of articulators to this day. In his own articulator design, he clearly manifests his own thought process by giving his articulator the visible centre of rotation, which in turn allows his spherical theory to describe the movement of the human stomatognathic system. As we go through more of the principles of the secure denture system, it will challenge more of the established concepts. We do not believe there are any geometric angles in the human jaws and joints, and we do not believe that both sides of the face operate in the same way during function. We do accept there are compensating curves, but they cannot be described as 4-inch radius curves. In fact, they are described as a parabolic helix, which is a curved curve. This will be covered more in other secure presentations.